Today we're going to be covering linear functions. It starts off by saying average rate of change or the slope. The average rate of change for a linear function can be calculated using the rise and run of a graph of a function. The rise is going to be the difference. So let me go ahead and write this. The rise is the difference in the y values of the 2 points. The run is going to be the difference of the x values of 2 points. So the slope of a line is the ratio of the rise to run for any 2 points on the line. We're going to focus at that bottom part. If I want to find the slope of something, it's just going to be a ratio. A ratio means it's a fraction where I put the rise on the top and the run on the bottom. Okay. When I say rise, well, actually, let me go ahead and address this over here too. Down here, we have what all these equivalent statements. And actually, I want to add one more. In front of that M, I want to write the word slope. So if you have 2 points, x1, y1, and x2, y2, we're just differentiating between the ones. Are any 2 points on the line, I can write this formula. Now remember, with subscripts, this is not saying like x times 1. This is just saying your first x, and this is saying your first y. This one's going to be my second x and my second y. So if I want to find the slope, that's the same thing as my letter m. That's the same thing as my rise over my run. When I say rise over my run, I mean delta y over delta x. And what delta y means is how much are your y's changing by and how much are your x values changing by. And if I want to see how much they're changing by, I just subtract two numbers. That's it. Okay, so let's go ahead and put this in a thought bubble because we're going to be using this a lot today. So the slope means m, which means rise over run, which means delta y over delta x, which means y2 minus y1 over x2 minus x1. You're going to hear me use almost all of those, maybe not this one as much, but I'm definitely going to be using these for a lot. Okay, so it says determine the average rate of change between the points of the pair of points 3, 4 and 2, 1. So if I want to find the slope, all I got to do, in this case, they gave me 2 points. I'm going to label this one my first x and my first y. And I'm going to label this one my second x and my second y. According to the thought bubble that I have up there, if I want to find my slope or my average rate of change, I just got to use the formula. So I'm going to write m equals, and the formula is y2 minus y1 over x2 minus x1. First time around, I'm going to go kind of slow on it. After that, we're going to kind of go fast. So when I say y2, what I mean is my second y. Remember, my second y is right here, which means it's going to be the number 1. So I'm going to write my m is equal to that number 1 minus, in this case, now I got to subtract my y1. My first y is right here. So instead of minus y1, I'm going to write minus 4. I'm done with the top. I'm going to move on to the bottom. The bottom, they're asking for my second x first. My second x is that number 2 minus my first x. Oop, I forgot to write x of 1, huh? Minus my first x. And my first x is 3. So now I just have to start calculating this. I'm going to simplify this. 1 minus 4 is going to give me a negative 3. And on the bottom, 2 minus 3 gives me a negative 1. That is to say my slope is 3. All right, let's move on to the next one. It says determine the average rate of change of the line between the pair of points -1, 9 and 2, -5. Again, same concept. If I want to find my slope or my rate of change, that's going to be y2 minus y1 over x2 minus x1. In order for me to calculate this, I just need to start labeling these things. So I'm going to call this my first x and my first y. I'm going to call this my second x and my second y. And I'm just going to substitute values. So my second y is -5 minus my first y is 9 over my second x is 2 minus my first x, which is -1. Now, here's where students will mess this up. I need to subtract this number here. So I need to write minus parentheses -1. Make sure you hit that minus minus or that minus negative. It's going to make a huge difference and students will forget it all the time. So over here, -5 minus 9, that's going to give me a -14. On the bottom, 2 minus negative 1. Remember that minus minus turns into a plus. So that's really 2 plus 1, which gives me 3. So I'm going to get a slope of negative 14 over 3. On the formative, it doesn't like when you put the negative on the top. So I'm going to just take that negative, squeeze it in the front, negative 14 over 3. It's the exact same answer, okay? But on the formative, it'll mark it wrong if you put the negative on the top. It's just a little picky. Technically, it's the same thing. All right, go ahead and let's try this last one. It says determine the average rate of change between the line and the parent points 0, 10 and 3, 12. So let's go ahead and call this one x1, y1. I'm going to call this one x2, y2. And my slope formula is y2 minus y1 over x2 minus x1. And we're just going to go ahead and start substituting these values. I just realized that during class, I was highlighting some of these numbers. So I believe my x1, y1 was green. Here's my x1, y1. And my x2, y2 was pink. So those pink numbers were going first. So let me go ahead and just, that way you don't lose points in your notebook when you turn them in. We're just going to go ahead and color code these things. My first ones go in the back, go in the back. My second ones go in the front, like this. Okay, sorry, got you caught up. Now we're just going to go ahead and substitute those values. So let's see. Y2 is 12 minus Y1 is 10 over X2 is 3 and X1 is 0. Running out of space, so that's going to be a 2 over 3. I check to see if that simplifies, and it doesn't. So my slope is equal to 2/3. That's my answer right here. All right, to determine the general slope of a line, you look at the line from left to right. So let's talk about that. When you're reading a graph, there's a couple of ways you can read this thing, and I want to make sure you're reading it correctly. So let's pretend I got this like curvy looking graph that looks like this. All right, and I ask you like, hey, is that graph going up or is it going down? Well, it just kind of depends on how you're reading it. If you were to read it from left to right, if I started on the left and I follow this graph, it looks like it's going up as I go from left to right. But if I went from right to left, it looks like it's going down. So we can't be, looking at the same graph saying two different things. So there's a standard way of reading it, which would be like reading a book. When you read from left to right. So we're going to be reading this graph from left to right. That means I'm going to start on the left. And in this case, my graph is going up. So you'd say like, oh, the graph is increasing. So just wanted to make sure that you got that. Now that I have that, let's go ahead and read the directions. It says, if the line goes up from left to right, then the slope is going to be positive, okay? Well, if it goes up from left to right, and then the slope is positive, what's going to make the slope negative? That's going to be if the line goes down from left to right. If the line is constant, or in other words, flat, we're going to say that the slope is 0. And the other one is if the line is vertical. Vertical meaning you got a line that's going straight up and down like this, then we're going to say that that slope is undefined, okay? Make sure you understand that because there's a big difference between this slope and this slope. Here, your slope is 0. Here, your slope is undefined. Essentially, why it's undefined is because you're literally getting a 0 in the denominator, which means you're dividing by 0, and that is something you absolutely cannot do in mathematics. So that's why we say that slope is undefined. All right, let's go ahead and jump to the next page. It says to graph a linear function, here are the steps. Step number 1, we want to write the given equation in slope-intercept form. Slope-intercept form is y equal to mx plus b. So if it's not written in y equals mx plus b, get it to look like y equals mx plus b. Today, all the equations are going to be done in y equals mx plus b, so you're not going to have to worry about it, okay? Step number 2 is going to be to plot the b, which is the y-intercept, on the y-axis. So step number 2, whatever your y-intercept is, or your b, you're going to plot it on the y-axis. Step number 3, and this is the one that's going to be a little bit challenging, we're going to use the slope to determine other points on the coordinate plane using rise over run. You're going to use the rise over run, which is your slope, to determine which way you're going to go. Remember, rise means up and down. So if the number is positive on the top, you're going to go up. If it's negative on the top, you're going to go down. And then the run, you run left and right. If it's positive on the bottom, you're going to run to the right. If it's negative on the bottom, you're going to run to the left. We almost never run to the left, okay? So we'll just leave it at that, and then you're going to see it as we move along. So let's go ahead and talk about this. Let's go ahead and, I'm sorry, we're not done. Step number 4, go up if the slope m is positive or go down if the slope m is negative from the y-intercept. That should take care of yourself if you're using rise over run correctly, okay? You should always have a straight line. And then step number 5, you're going to graph all the points. You should have a straight line with all the points on the same line. If you end up with something that's not straight, you are doing something wrong, okay? All right, let's go ahead and graph these. Sorry, I don't know how I lost that H. Let's go ahead and graph these. I'm going to graph y equals to 2/5 x minus 3. Step number 1, I'm going to put it in y equals mx plus b form. It's already there. Step number 1 is done. Step number 2, I'm going to plot the b. My b, or my y-intercept, in this case, is -3. So where I see a -3 on the y-axis, I'm going to put a dot at -3. That is my y-intercept. I also call it my starting point, okay? So we are done with step 2. I plotted the y-intercept. Step 3 says use the slope to determine the other points using rise over run. Okay. So in this case, it's kind of easy because it's already a fraction. My rise is 2. That's a positive 2, so it's going to go up. And remember, the bottom number is your run. You're going to go left and right. Since that 5 is positive, I'm going to go to the right. Remember, we hardly ever go to the left. So that pattern says go up to right 5, up to right 5, up to right 5 from your dot. So here is my dot. I'm going to go up to right 5, 1, 2, 3, 4, 5. And right here, I'm going to go ahead and place a dot. Now, the tricky part about this is you got to keep doing it until you can't do it anymore. So now I'm here, and I'm going to continue my pattern. I'm going to go up 2, 1, 2. I'm going to go right 5, 1, 2, 3, 4, 5. And right here, I'm going to put a dot. I would love to do it again, except for I'm out of graph. So I'm done going up to right 5, up to right 5. However, to get the rest of your graph, you're going to go in the exact opposite direction. So since we're going up to right 5, up to right 5, up to right 5, the exact opposite would be to go down to left 5. So from my dot, I'm started back in the beginning, I'm going to go down to 1, 2, left 5, 1, 2, 3, 4, 5. I'm going to put a dot right here. If you did this correctly, then that dot should be lining up perfectly with the other dots. If not, you did something wrong, okay? And again, we're going to continue that pattern until I can't continue it anymore. So from here, I'm going to go down 2, 1, 2, left 5, 1, 2, 3, 4, 5. We're going to put a dot right here. And once you're done with all of that, you should get a ruler and connect this using one straight line. If those dots are not falling on that line, you did something wrong. Okay, so that's always an easy way to check. Okay, hopefully that made sense. I'm going to go a little bit quicker on this one. First, step number 1, I want to graph it. It's already in y equals mx plus b form. So we're going to jump straight to step number 2. Step number 2 is to find the y-intercept and plot it on the y-axis. My y-intercept is 7. So on the y-axis, I'm going to look for the number 7 and put a dot. And I'm going to highlight it as well, just so we know where we're starting. You know what? I also just realized that I forgot to draw my pattern. I was going up 2, right 5. So in green, I'm going to go up 2, right 5. Sorry about that. Hey, my slope is -5. That's my rise over run. Unfortunately, I see the rise is -5. I don't see any run because it's not a fraction. Our slopes, you want to write them as a fraction when you're graphing them because it makes it easier to see what's happening. How do I change -5 into a fraction? I just put it over 1. So when I say my rise is -5, remember the rise is up and down. Because that because that number is negative, this means go down 5. And look at that 1. The 1 on the bottom is actually a positive number. So we're going to run to the right one. Remember I told you, we hardly ever run to the left, okay? So my pattern is telling me to go down 5, right 1, down 5, right 1, down 5, right 1. So I'm going to go ahead and start right here. From here, I'm going to go down 5. 1, 2, 3, 4, 5. Right 1, put a dot. So I'm going to put my dot right here. And you keep doing that pattern. Actually, before I forget, we went down 5, right 1. I'm going to go ahead and do that pattern again. From this dot, I'm going to go down 5. 1, 2, 3, 4, 5. Right 1, put a dot. 1, 2, 3, 4, 5. Right 1, put a dot. I'm going to try this one more time. I'm going to go down 5. 1, 2, 3, 4, 5. Right 1, put a dot. And it looks like that's as far as I'm going to be able to go. I would love to go the other way. If I went the other way, instead of down 5, right 1, I would go up 5, left 1. But it looks like I'm not going to be able to fit that either. So I'm going to go ahead and take my ruler. And I'm just going to go ahead and connect these lines going straight. And we are done. All right, we got 2 more examples, and I want to make this video short, so I'm going to go a heck of a lot quicker than I did before. Remember that there's already in y equals mx plus b form, so step number 1 is done. Step number 2, we're going to take our b, which is 3, and I'm going to plot that on the y-axis. So on the y-axis, I'm going to put a dot at 3. And I'm going to go ahead and highlight it. My slope is 1/2. Now remember, the number on the top tells me up or down. Because it's positive, I'm going to go up 1. The number on the bottom tells me left and right. Because it's positive, I'm going to go right 2. So my pattern is to go up 1, right 2, up 1, right 2, up 1, right 2. So let's see. From here, I'm going to go up 1, right 2, put a dot. 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 Remember, we keep going on our graph till I can't go anymore, okay? Now that I have those set up, I want to do the exact same thing, but going in the opposite direction. Before I do that, though, let me go ahead and draw what my pattern was. It was up 1, right 2. That's how I'm getting to the next dot. If I want to do the exact opposite to go in the other direction, I'm going to go down 1, left 2. Let me show you a mistake. Don't draw this. Let me show you a mistake of what students are going to do. They're going to try to say like, oh, down 1, left 2. And for some reason, they're going to put a dot right here. Just look at that thing. Does that look like it's part of the same line? No, all of a sudden you're going in a different direction. So that should be an automatic check that you're doing something wrong. Because again, you went down 1, right 2 instead of doing the exact opposite, which should be down 1, left 2. So from this dot, I'm going to go down 1, left 2. If you notice, it's starting to follow that line again. We're just going to continue that pattern. Down 1, left 2, put a dot. 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 This is where I get to say I've been doing these graphs, no joke, guys, for about 30 years. So I can do these relatively quickly. that doesn't mean you should do them relatively quickly. You should do them at the pace that you're going to get them correct. Okay, so don't worry about going fast, worry about getting them right. On the next one, I am definitely going to go fast though, because again, I don't want this video to take forever. So step number one, the slow, put it in y equals mx plus b. It already is. Step number two, we're going to start with our starting point, which is -1. -1 would be right here on my y-axis. Let me go ahead and put a dot like this. Now that slope of -3/2, notice that the negative is in front. I don't like that negative in front when I'm graphing. So I'm going to move that negative to the top. It's going to be the same thing, guys, because if you notice -3/2 like this is a negative number. But if I change it to look like this, you have a negative divided by a positive, and guess what? This is still going to be a negative number. So I can change it. I can move that negative to the top. You just can't move it. You can't do this. Put it on top and bottom, because a negative divided by a negative, I'm changing it, and all of a sudden it's positive. So don't do that. Okay, you can either move it to the top, you can move it to the bottom, but you can't move it to both. All right, I'm going to move it to the top. Why am I moving it to the top? Because now I know that this is going down 3, right 2. So my slope is -3/2, which means my pattern is go down 3, right 2. Let me go ahead and do that right here from this point. I'm going to go down 3, 1, 2, 3, right 2, 1, 2, and I'm going to put a dot right here. Continue with the pattern. Go down 3, right 2, put a dot. Down 3, right 2, put a dot. If I want to go in the opposite direction, whoops, before I do that, let's go ahead and show my pattern in green. That was down 3, right 2. If I want to go in the opposite direction, I'm going to do the exact opposite. So instead of down 3, I'm going to go up 3. Instead of right 2, I'm going to go left 2. So I'm going to go up 3, left 2, put a dot. Up 3, left 2, put a dot. Up 3, left 2, put a dot. And if I try to do it again, it's not going to allow me. I ran out of space. So this is good enough. I'm going to go ahead and draw my line that connects all of them. Again, if it's not connecting all of them, you did something wrong and you need to check your work. Okay. That is it for the notes today. Hope that helped. And as always, if you have any questions, feel free to ask.